In RT2 Lesson 2, we were looking at how to add like radicals. So if I look at problem number 14, subtracting can be done the same way. And what I notice is that none of these radicals are alike, but all of them can be simplified. For instance, the first one, the perfect square that divides into 12, is square root 4. So this becomes 7. Square root 4 times square root 3. The perfect square that divides into 27 is 9. That becomes square root 9 times square root 3. And lastly, the perfect square that divides into 300 is 100. This becomes square root 100 times square root 3. I can simplify each of these. Square root 4 is 2, making 14 square root 3 for my first term. Square root 9 is 3, making 15 square root 3 for my second term. Square root of 100 is 10, making 60 square root 3 for that third term. These are now all square root 3's, so I can add 14, subtract 15, and subtract 60 to get my whole number part. And behind that we will have the square root 3. Problem number 11 is solved the same way. The perfect square that goes into 24 is the number 4. The perfect square that goes into 150 is 25. This becomes, the first term is 10 square root 6. The second term is 32 square root 6, and you can now simplify the rest of that one. To solve problem 15, you need to find the perfect square root part of 44, the perfect square factor of 22, and the perfect square factor of 99. 4 divides into the square root of 44. That becomes square root 4 times 11. 22 becomes, well, you know what? This one is trickier. I can turn it into square root 2 times square root of 11. There is no perfect square that divides into that. However, this square root of 11 will make it easy for us to simplify later. The third term in number 15 becomes 9 times square root 9 times square root 11. So the first term becomes 8 square root of 11. The next term becomes 2 square root 2 square root of 11. And the last term becomes 27 square root of 11. Two of these terms can be added to look like this. 8 plus 27 is 35. I have this 2 square root of 11, or 2 square root 2 that I can put like this, and multiply all of that by the square root of 11.